welcome to week 2, day 1 for IS50B. Your homework assignment is actually going to be continuing to work on your third-person template and adding a animation blueprint that does jumping and crouching and things like that. Dog, yeah, it's kind of a cool background. So I'll post, I don't know, some tutorial on that because I want to lecture on rasterizing. So there's a tutorial. I just send that on Discord. It'll be up on Canvas. Just run through that, and it'll show you like a state machine, how you can transition between different states and use variables and things like that. Figure out if you're jumping, if you're crouching, if you're running, that kind of stuff, and use different animations. Did you guys have any questions about the previous one? You had some trouble with the animations? Okay, let me pull that up then. The let me show you what it's supposed to look like, at least for today. I haven't made the full blueprint myself. Maybe I can work on it a little bit right now. I do want to lecture on rasterization though today. Wasn't fluid at reset and glitched after every loop. Yeah, I think I know exactly what you're talking about. It's like when the character runs, like he'll like run forward and then flip back and then run forward and then flip back and then run forward and then flip back. Is that what you're talking about? Yeah. Mm-hmm. Yeah, so the reason for that, there's two different places where you can stop that from happening. So the first is on the Mixamo website. And we logged you out. Okay. I don't know what difference it makes. Want to sign in with your password? Not really. All right. So when you have like a sprint animation or something like that, sprint forwards. You see how the scary clown is running forwards. What's happening is that when you're doing your animation, it's actually animating off the origin of the world is like right here, right? So, like right there. And so, and then when it finishes the animation, it comes back to the beginning. And so your origin, your local origin, is moving forwards, but the animation is being drawn like that ahead of it. So what you can do is set it to do in place, and then it won't move off the root. It'll stay in place. So if you export it like that, you can do that. I downloaded the entire pack, and all of them are not in place if you do that, I think. Yeah, if you just download the whole thing, it's not in place. So you have to fix it in Unreal Engine instead. You can, I mean, if you want, but like I downloaded the entire Sword and Shield movement pack, and none of them are in place. So that said, you have to fix each of them individually. So I don't know if it's a win either way, but this is what it looks like. So if you want to fix it, so like where is my? Yeah, let's say we're going to use Scary Clown Walk, right? So what you do is you turn on Enable Root Motion, and if you do that, then the bug goes away. Because so if I turn off Enable Root Motion, you see how the thing slides forward. If you turn it on, then it stays in place. So that's the fix right there. Now that is a great walking animation. He's like cutting his own throat with a sword. So yeah, you see a man coming at you like that, you just know he's afraid of nothing. So what I actually did was I added in that walk kind of in the midpoint here. And so like when you're idle, he's standing like that. Then as you start walking forward, he starts doing the Scary Clown Walk like that. And then when you go even faster, then it transitions just into a normal walk. Actually, I don't want to do a walk. Let's do a run. Sword and Shield run. Let's put that there, like that. There you go. So as you go from stationary to walking to running, blend spaces are really cool. And he fears nothing, not even ridicule. Yeah, not even the sword at his own throat. That's just how hardcore he is. So this is something called a blend space, and a blend space is used to smoothly transition between different animations. Back in the day, we would just play an idle animation if you're idle, and then when you start running, it just plays the running animation, and then you stop, and then it runs, and it stops like that, and it looks a little jerky. So what you can do with a blend space is actually have different animations. This is set to blend based on the speed of the character. This doesn't take place automatically, by the way. You have to do all of this. You have to create a variable called speed and set it, and it's a little annoying. I wish some of these things could be done automatically. You have to set the max speed so that this is 100% at 380 and it's 50% here. And so, anyway, once you have it set up though, like you can see it'll just transition very nicely between the two. So the idle animation and the scary clown walk do that, and then you do scary clown walk / run, and you drag it up, more running, and it's actually really cool. It's a really neat effect. You can also do 2D blend spaces, which maybe I'll show in a second. So yeah, so if we do that and close out here and come into here, you can see it. Yeah, I only have WAS Steve. So I can either run at full speed or stopped. Let me see if I can hook up a game controller to this. Yeah, it's not letting me walk. It's either full forward or not. That's annoying. Okay. So yeah, if I set up the inputs properly. Inputs, trackpad. Should be gamepad left, thumbstick x-axis, and y-axis. Oh, that's right. Left and then left. Yeah, this should allow me to do slower walking. I don't know. Whereas enable root motion again, it's on each individual animation. So if you click on Scary Clown Walk, oh right, I was going to show you what it looks like if it's off. So let's go to Walk Run Animation here, and delete you, and let's go to Scary Clown Walk over here. And so now when I run at full speed, it should show you the, oh, did I? It's right here. So if I turn that off, then when it walks, you see how it does that weird bug? It's because it's animating out of the root. It's animating out of 0, 0, 0. And if you turn on root motion, then the root just moves with it. And it looks a lot better. So you do that. And then when you run, and if you want to make something really horrible, on your blend space, it gets back on your blend space over here. So this is the animation to play when it's idle. This is the animation to play at full speed. You can do horrible things like the snake hip hop dance. And so when the thing runs, it's going to do the snake dance, and the neck is going to look terrible. Ah! Oh, Lord. Oh, my goodness. Yeah. That is the stuff of nightmares right there. Okay, so I'll put it back on to run. There. Okay. You gotta take that guy to the club. Yeah, I don't know, with a neck like that, I'm a little afraid of if he's human or not. Yeah, the knees look a little weird on that animation. Maybe that's why I was using the walk animation. He's like really high stepping it there. Okay. Okay, so, and then to the chiropractor. Whoop! Okay, so the sword and shield run, sword and shield idle, speed, rate scale, snap to grid, yeah. Okay, so this is a blend space, and basically you got to set up a couple different things to get a blend space to work. The animation blueprint over here is how speed comes from, and there's no like just built-in speed thing. So what you have to do is every tick that the animation updates, you get the owner of the animation blueprint. That gives you the player. You get their velocity. You do vector length. If you remember, vector length gives you the magnitude of the velocity vector, which is your speed, and then you set it. Now this thing here is something a lot of people forget about. The update animation can actually be called prior to the thing being placed into the world. And so you have to be very careful with that and only do things if the thing is actually in the world. So, yeah. So that is that. And so what it's doing is that it's setting a variable called speed. You can see there's a variable over here called speed on the blueprint. And then the animation can pick up the speed off of the animation blueprint that way. Okay. Okay. So let's do this maybe with a 2D animation blueprint. So we've got 45 minutes left. Nah, maybe next time. I think that's enough for now. So get that working and post it on Canvas when you get a chance. We'll bail out of there for now. The tutorial I gave you will walk you through a more complicated animation blueprint. The last one was very simple. It just has the blend space attached to the final pose. But the next one will show you how to do a state machine, so you can have different movement modes. I think it might have a 2D blend space in it, so you can see like how to make a guy strafe, like have different animations for moving sideways and moving forwards. You get the direction, you get the relative direction of the player. So if you're moving like a 45-degree angle, it'll give you like 0.5 or something like that, and then you can blend strafing motions with the stopping and running motions as well, and it looks pretty good at that point. And then it'll show you how to add in jumping and crouching and sprinting. It might be in that video, it might be in some of his other videos. It's Matt Asplund. He does a pretty good set of videos on Unreal Engine 4. Anyway, so credit for where credit is due. Okay, so let's talk about rasterization. Okay, so rasterization means drawing pixels on the screen. Okay, and you guys are going to have a couple different options for doing this year. In semesters past, I've been doing it on the server because I've got a colors library that allows you to treat PuTTY like a very simple 2D screen. You can draw colors to the different spots on the screen. I've also been working on SDL more and more these days, and SDL is like the underlying library that like Valve uses to draw things on the screen. So it's a pretty widely used interface for underlying hardware. You can read from game controllers. You can draw things on the screen. It might be worth learning. It's definitely a pain to set up, whereas the whereas my colors library is literally just that. At the same time, learning how to set up Visual Studio and get include files and libraries and things like that installed on Windows, probably a good experience for you too, so you have some experience outside of the Unix world. I don't know. We can talk more about that later. You can tell me what preference you have if you want to do it on the server or on SDL. Anyway, so the way that my colors library works is you can move the cursor, and it takes a row and a column. So if we move it to row 10 and column 5, we can then output hello world. Doesn't need a library, you don't have to link in curses in, any of that stuff. If you run it, it just prints hello world right there. And if you move the cursor back up to the top of the screen, or the top left corner of the screen is 0, 0 in screen coordinates. What does previous projects in this program look like? Here. If I run it, it prints hello world down here, then it moves the cursor back up here, and then it redraws the prompt. So you can draw things anywhere on the screen. We have done things like edgelord, where it will randomly generate maps and things like that. We're going to talk about Vrony and Dirichlet domains and things like that. So generating a Vrony diagram using the colors library. That's actually the second assignment in it. Q.reference. The basic one is it just makes a random map. So it's like you're going to play a game of Civ or something like that, and you want to make a map. Do that. And so the interface, I don't know how things you're pulling up work. So it's a server? Yeah. Yeah. So maybe have you done C++ programming before, Avina? Let's scratch the surface. Yeah, maybe I'll have you guys do STL this semester, or maybe your choice. I don't know. But anyhow, the way that my library works is that this command here, move cursor, moves the cursor, the green square, moves that to the given row, the given column, print something out, move the cursor again. You can change the color if you want, so you can set color to be 25540. If you do that, then it'll draw hello world in color. They take 8 byte integers inputs. Yes, it ranges from 0 to 255. That is correct. Maybe make that 80. A little more orange now. You can set the background color to be white. 255, 255, 255 is white. So, cool. You know, that's basically all you need to know for any of my homework assignments. That's the entire library that you need to know. I do have something that makes mouse clicks work, but you don't have to worry about that right now. So, basically all you need to do is, like, if I'm going to give you an assignment to draw a line, then move the cursor to a spot and draw a white pixel or something like that. After the maps generate, what does it do, or does it only generate a map? So for that assignment, there's a couple different assignments. CD, edgelord. Great, the colors are all screwed up. So set the colors and run it. There we go. If we go into, what's it, edgelord, then there's a conquering system. So Jerusalem can conquer Brussels. Wait, no. Yeah, so Jerusalem can conquer Brussels. Kabul conquers Jerusalem. Armagh conquers Kabul. Hong Kong conquers Geneva. Prague conquers Hong Kong. So you see how the country borders, you know, change and things like that. So pretty cool stuff. So, I don't know. I haven't decided yet what I'm going to do with you guys, whether or not to do it in STL or in on the server. But basically, these are the three. You don't even really need that one. just moving the cursor and drawing something. So what we're going to do today is talk about how to draw a line. Okay. So do you guys remember algebra? Barely? Y equals mx plus b. Okay. Yeah, let's do that. It has letters in it, sure. So mx plus b. Okay, so let's just comment this out here. Do I have caps lock on? Okay. So these are the three functions you need to know. That resets the color there. I'm literally reviewing slope-intercept form. Okay, all right. So if we have y equals mx plus b, that's a line with a slope. Okay. So, all right. Let's just do that. Double slope equals read. Please enter m. Does anyone know why m is slope? I'm actually curious about that. Why is m slope? Somebody look that up. Double b. Y-intercept. Why is B the y-intercept? Why is it not I? I don't know. Like that's the worst thing about math, in my opinion, is just like, if you can get through the terminology, like it's not really that bad. It says IDK, lol. It does not know why the letter M was chosen for slope. To climb is Monte. What? It should be S. S is slope. I don't know. Okay. B is intercept. Does anyone know why B is the intercept? I don't know. It's B for bad. I can't even think of something funny to say. Bat. I don't know. I got nothing. Okay, so yeah, so that'll define a line, right? This will define a line, and then we need to draw it on the screen. Draw a line on the screen. So get terminal size. So, okay. Okay, so this will tell us how big our window is, how many rows, which are horizontal lines, and columns. So it's going to give us like how big we have to play with. What's going on, Bedencourt? What's an idea for an action roguelike where enemies shot in a line, but you had one turn to move away from the line, damage you, dodging bullets? Okay. A is for slope and B was next. A is not slope though. So they changed A to be N, and then B was just left. Should be N. Slope should be N in that case. And this is like, and you wonder why middle school kids have trouble with algebra. Just call it S. I don't know. Like A, maybe? I don't know. Okay. A is for slope and B is for intercept. That makes sense, I guess. Makes sense. But if we use M, I don't know. It's so weird. Okay. So let's draw a line on the screen. So what row is the, remember our coordinate system is 0, 0's in the top left. So if we have a positive slope, it's actually going to draw down the screen. That's fine. We can fix it in post-production. So what? So we're going to just start at every column. So for int I equals 0, I is less than number of columns on the screen, I plus plus. For every x, how do we know what the y value is for a given x? So if we're at x equals 10, how do we compute the y value there? Our x value is just going to be I is going to start at 0, go across the screen. How do we find out what the y value is at every point? Can we use Python? I guess. I don't see why not. So we've got a slope, we got a y-intercept. What's our y value? Okay, time to go into OneNote. So if we have y is equal to mx plus b, let's say the user's typed in 5 for m and 10 for b. What we're going to do is we're going to go from x is equal to 0. Let's say we've got, I don't know, 80 columns on the screen. So for each column, we're going to plug in the value of x there. So let's say we're at x is equal to 10. Yeah. So what is the y value going to be? So that's the y-intercept there. Comes up this way, right? So what is the y value going to be when x is 10? Yeah, 60. 10 times 5 is 50, plus 10 is 60. Okay. So this is just, the slope is 5. The y-intercept is 10. So just for every, so what we're going to do is for every x value, we're just going to figure out what the y value is by just doing this. So when x is 0, what is y? 10, yeah. And then when x is, I don't know, 80, what is y? 410. It's going to be off the screen. So we have to make sure not to draw things off the screen, or the cursor actually goes crazy, because the cursor will, I think, loop around if you don't do it right. So so the column is just I. So I is going to go from 0 to 80 or whatever maximum columns is. And then the row, which is the y value, this is the x value. It's just mx plus b, right? So m b x y. How about that? So y is equal to m times x plus b. What do you guys think? That seem like good algebra? Okay, so now we just need to draw the pixel on the screen. So for every column on the screen, we'll just draw a white pixel at that row in that column if it's within bounds. So if x is less than 0, or x is greater than columns, or y, which can't be, but, or if y is less than 0, or y is greater than rows, and I think we don't want it drawing on the bottom row either, or even the next to the bottom row. Rows, we'll just cut it off a little bit early. Rows minus 1. Then we don't draw anything. cut this off. Because if you draw off the right side, it wraps around to the next side. So we'll just cut it in a little bit. So if x is less than 0, or if it's gone off the right side, or if y is less than 0, or if y is off the bottom side, don't draw anything. Otherwise, we will move the cursor to y, which is rows, and x, which is columns. And set color to be black. Set the background color to be white. So we're just going to draw basically a white box on the screen, because we are just going to see out a space. Okay, so we see out a space. The foreground color is black, the background color is white, so it's going to draw literally just a white rectangle on the screen. And when we're done, we will just echo reset and move the cursor back up to the top, I guess. Please enter the slope. We'll do a slope of 1, a y-intercept of 0, and there we have a 45-degree line. This is called line rasterization. So line rasterization means you go from a mathematical construct of a line to having pixels drawn on the screen. You have some sort of output buffer. In this case, we're actually drawing directly to the screen. But usually you have like a 2D buffer, and that after you're done drawing into it, then you swap the buffers. You usually do double buffering. You swap the buffers, and then the new thing appears, and you draw into the other buffer. You clear it, and then draw into the other buffer, and then switch it back, and switch it back. That's normally how you do stuff. In this case, we're actually just drawing directly onto the screen, which is fine. So let's explore this a little more. So if we have a slope of 0 and a y-intercept of 10, we get a line, a very beautiful line going horizontally. Okay, so good so far. So far, so good. Yeah? Have I destroyed any of your brains with the algebra here? Like, I really try to not to go too hardcore on the math. Okay. It's weird that it's upside down. Yeah. Because 0, 0 is the top left corner. And as y increases, y goes downwards. And so if we wanted, we could fix that by...
Oh, you picking up the kid?
The kid?
4 o'clock, Wednesday.
It's Wednesday?
Oh, it's Tuesday.
It's Tuesday. Jeez. Huh? Give me a heart attack, dude.
Sorry. Okay, so you're good.
Yeah, thank you.
Pick her up?
I will pick her up when class is over.
Oh, what time?
Half an hour.
Okay.
I should know this stuff, yet it isn't working. Yeah. So if we wanted it to go from the bottom up, let's see, columns minus that. You might want it up like a row or something. The power of algebra compels you. The power of algebra compels you. All right. Let's see if that works. Slope of 1, y-intercept of 0. I use columns instead of rows. That's why. Oops, rows. There we go. I failed you, teacher. It's all right. Slope of 1, y-intercept of 0. There we go. So it is now coming up from, and I am not drawing anything on the bottom 2 rows just to avoid, because if you draw something on the bottom row, Putty scrolls the window and it looks really bad. So I just try to keep it away from the bottom a little bit. Maybe we could do rows. Let's try that. Yeah, I guess that works. So that's a line. What do you guys think of our line rasterization algorithm? So basically we just sweep for every x value, we just compute the y value and then move the cursor to that spot and draw a white box there. So for every x value, technically I could have just called this x, huh? Start at the left side of the screen, go to the right side of the screen. Yeah. Technically, yeah, it's fine. And then this is the algebraic equation for a line. Slope times x plus the y-intercept. Now, let's look at what happens if we do a steep line. What happened? What happened? Does that look like a very good line? Aren't enough pixels. Well, I don't know. We're going 1x at a time, and we go 1x to the right, and then the y goes up by 5. We go 1x to the right, and y goes up by 5, and 1x to the right, and y goes up by 5. Do we have a solid line anymore? Or is it broken? What do you guys think? What's the problem here? Broke. How do we solve it? What's the solution? Connect the dots with a marker. That's a one-time solution. You make it go up 5, then right 1, and fill it all in. Okay. But we're only doing 1 pixel draw per x. So what we could do is be like bool steep if m is greater than 1. Slope of 1 is a 45-degree angle. If the steepness is above 1, it should be the absolute value, I think. So if it's steep, that means that we need more pixels per, column, right? And so a very clever solution to this is rather than drawing, if it's steep, like if it's like really vertical, rather than drawing on every x, what we do is we draw on every y instead. And so if it is a steep line, we do one thing. If it's not steep, we do our other thing. 1, 2, 3, 4, 5, 6. And so what we're going to do is switch it around. So for starting at y equals 0, y is less than rows y plus plus. Now we need to figure out the x value. What is the x value? Anyone? Yeah, it'll be if you had a slope of 5, slope is now 1/5, right, or whatever. Right? What is the algebra? In order to do game development, you kind of gotta do at least a little bit of algebra. It's inescapable. So if y is equal to mx plus b, then y minus b divided by m equals x. right? You subtract b off both sides, divide by m. Does that look right to you guys? This is the equation for a line. This is the line equation. A line equation. There's other ones as well. You see that? Subtract b off both sides using the powers of algebra. You get y minus b on one side and mx on the other. Divide both sides by m. You end up with that. So we just need to translate that into code. So starting at 0, going... this isn't gonna... No. Let's just start off not worrying about flipping the thing around. So starting at row 0, the top row, going down to the bottom, x is going to be equal to y minus b, quantity divided by m. Okay. Let's try that. Again, it's now the y is going to come up out of the top right corner again, but it should be good. We can fix that in later. Okay, so, oh, did we not recompile it? Maybe that would help. There we go. Hey, check that out. Cool. Again, it's coming out of the top right corner, but we can fix that. Why is the start a different length? What do you mean? When I finish, I move the cursor back up here, so the Unix prompt is overriding this one pixel here. Slope of 10, y-intercept of 0. It's almost a vertical line. Slope of 2, y-intercept of 0. Okay, so that's a fairly basic line rasterization. Remember, rasterization means you go from some sort of mathematical construct to actually putting pixels on the screen. That's what to rasterize means. Triangle rasterization takes a triangle and puts a triangle on the screen. Okay. So if we want it to go bottom up, looks pretty good. So, yeah, there's obviously some rounding errors and stuff like that, but the next step would be to do what's called anti-aliasing. And so you can see how we have that very visible stair-step pattern there. What we actually want to do is, as we're sort of navigating around, sort of accumulate how far along each one of these little segments we are. So every time we go advance to the next column, then it'll sort of build up and build up and build up like a percentage. Like we're at 5.5, 5.6, 5.7, and then we can use that to draw in another pixel next to it. You guys understand? So anti-aliasing is really important in video games. You guys have all seen anti-aliasing before, right? Like it tries to blur the edges of these stair-step patterns, right? There's a lot of different techniques for doing anti-aliasing. We did talk about an IX58. There's temporal anti-aliasing that tries to average it out between frames. There's just a bajillion different ways of template patterns and all these things. Yeah, there you go. So what we want when we draw a line like this is to not only draw a line or a pixel at a time, we actually want to draw 2 pixels at a time. We want to draw the current pixel that we're at, and we want to draw one to the right, and the percentage of which one we draw is based on how far along we are. So if we're like right here, if we're at this spot right here and we just hit a new column, we could just draw this pixel fully white. That's fine. But then when we get to here, maybe it's like 5, it should be column 5.5. Well, if it's column 5.5, that means we're like halfway to column 6. And so we'll draw half the intensity on column 5 and half the intensity on column 6. And then the next row up, we're going to be on column 5.8. So we're going to draw 20% in column 5 and 80% in column 6. Does that make sense? So we're going to actually look at the decimals in our doubles and use that to figure out which ratio we should draw from one column to the next column. All right, see you, Bencourt. Yui, does that make sense? Like, you know, as you go along, it should smoothly transition from column 5 to column 6 as we're going up. And then if we're doing a like a 0.5, doing a flat thing like that, then as we go this way, it should smoothly transition that way as well, so we don't have these stair steps. Okay, so 0.25 and 0, so we get these. So as we're about to go up to another row, it should already have some white there. You know what I'm saying? So instead of it just being all black or all white, we're gonna kind of shift the intensity sort of smoothly over time. And we're limited by the technology of our time. We're in a 1970s graphics era here. But I don't know. I really like it because, like, this is it. This is all it takes for you guys to draw, like, you know, to raster graphics, and you don't have to install libraries or do anything. Like, to get STL working on my computer here, you have to add the STL folder to your path. My path is already at the maximum length allowed by Windows, and why that's a thing, I have no idea. And so then I had to put my STL2.dll into a directory that was already in the path, and it's just like, I don't know if I can trust my students to do that. I don't know. You guys are smart. You can probably figure it out. It's just like, why is there a limit on the path length in Windows? It like, why? It doesn't make any sense. It's like, I want to add a new folder so I can find a DL. Nope. Nope. Sorry. Okay, so yeah, let's do a little anti-aliasing. This will be my first time actually writing an anti-aliasing algorithm. I understand the theory. I've never actually done it before, so we'll do it live. We've got 17 minutes left. I'm sure it'll work right the first time, because that's how it always goes here on IS50B. Okay, so we're going to get a y value. Y value is the row, so we're going from columns on this one, and then we'll just replicate it up there for the other one. So if we get a column of like 5.5, that means it should be half in column 5 and half in column 6, right? You guys understand? So if we're getting a y, oh, it's an int. I can't do an int, can't do an int, can't do an int. You need to be a real boy. Double y. Okay. So we're going to get a double, and we are just going to get a percentage out of that, and let's say double percentage is going to be equal to y minus casting y to an integer. And so if we have 5.5, this will give us 0.5. If it's negative, it'll give us a negative number. We don't allow negative screen coordinates, but I'm still going to absolute value this just because. Okay. So we're going to draw 2 pixels. And we're going to draw them at different intensities. So we can't just do this anymore, unfortunately. So the percentage of the next guy is this one. Okay. So the color. So if the percentage is 0, the current spot's going to be drawn in white, and the next spot's going to be drawn in black. Okay, so if percentage is 1, then we want 0. Okay. Okay, so we'll do it like this. Current percentage is that, and double the next column percentage is minus current percentage. Or I could just do it like this. So this is percentage of intensity for the current column, and this is the percentage intensity for the next column. So if we get, you should be drawing on column 5.5, then our current column will get half the intensity, and the next column will get half the intensity. And so as it goes up, it's going to go like 1090, 2080, 3070, and it's going to smoothly transition from one to the next. So the next percentage is the percentage the next column gets. This is the percentage the current column gets. Okay. So the color, the current one, okay, right there. Okay. So the color, set background color, it's going to be equal to 255 times current percentage, 255 times current percentage, 255 times current percentage. Move the cursor to the spot, draw it. Now we're going to move 1 to the right. So the background color is now going to be 255, 1, 2, 3, 4, 5, 6, 7, 7s. Next, escape, dot, dot. And then we're going to move the cursor 1 column to the right. Are we going to go out of bounds? Probably not. So the y value, the row is still the same, but okay. And then we're going to draw another one. So rather than drawing one box at a time as we go up, which will give us that ugly stair step pattern, what we're going to do is we're going to draw 2 boxes, and the relative intensity of them is based on how far along we are. And there's faster algorithms to do this, by the way. There's if we were doing this back in the old PC, x86 days, 386, whatever, this would be far too slow to be practical. But we're living in the future, so it's okay. So we'll do a in 0.25 and B, and there we are. Oh, interesting. No. No, it needs to be row instead of column then. Okay, sorry about that. So instead we're going to go row minus 1 higher. If y is less than yeah, Windows is a pain to deal with, but it's probably good for you. Okay, so we're just going to move up to the next row above where we were, and then, yeah, there we go. Okay. This won't work with like negative slopes and things like that, but we can't draw those on the screen anyway. 0.25 and 0, and there you go. So as you see, as it goes along, this is perfectly white, that's black, and then that intensity is backwards. Interesting. That should be down there. Did I do this backwards? Oh. Oh, that's the next percentage. Yeah. I did have it backwards. Did I? Did I switch next and correct? Yeah, when it gets in the next one, it's correct. You see that? So like this one should be all white up here. Yeah, I probably made a stupid mistake somewhere. Let's see here. If next percentage is 1, it'll be 255, 255, 255. And that's the row above. And then when we get to the next one, the next row up, it turns more and more white. And then when we get to the next row up, it should have 1 for current percentage. So it should draw that as white, and then the next one should be black. It's because we're... Oh, I know why. Yeah. Because we inverted the y-axis, so this should actually be y++. It's y++ because, yeah, we flipped the y upside down, and then, yeah, okay, that should do it. You're bad. No, it's fine. It's good for my brain to hurt every once in a while. And there we go. So, no, it's still not doing it. Did I recompile? No, it's still not doing it. That's correct. That's correct. That's correct. It's just that pixel right there. It's not drawing properly. That one needs to be reversed when it's 1 and 0. All right, I'm going to take out the inversion. Okay, that's pretty good. It's pretty good. So you see how it's, as it goes along, it's pulling intensity from one row to the next row. And when it hits 0, then it starts on the next one. And so it's always splitting it across the 2 rows. So it looks pretty good. Looks pretty good. 0.05 and 0. Yeah, so that's 20. So it spans like 20 different intensity levels. Not bad, not bad, not bad. Yeah. So there you go. There's an anti-aliased line algorithm. We haven't done it for the steep lines, but it's the same thing. Oh, right, because it's steep. 0.9. So you see how it's anti-aliasing coming down? Doesn't look bad. Doesn't look bad. So yeah, this algorithm is using all sorts of wasted instructions. You know, it's using floating point numbers, and all these things would have been, you know, absolutely horrifying to Michael Liabrash or any of the geniuses that had figured out how to do all this stuff. Like, what they did is they would accumulate an error. So every time you do this, it records how much was left over the thing, and it would accumulate that every time. And so basically, you would know that every 4, you need to go up 1 row or 1 column or whatever, and then it would use that 4 to figure out the relative things. And yeah, there was a lot of really smart people back in the day who really scrounged for every bit of performance out of it. For me, I don't care. Okay, so we just need to implement this in for the vertical lines, and we'd be done. Okay, any questions about this? So all we did was we just used the algebra line equation. Given every x on the screen, we figure out the y value, and then because we can only render to discrete points on the screen, we see how far above the current point we're supposed to be. So rather than rasterizing to 5, we're trying to rasterize to 5.5. Okay, so we'll split half the intensity on the current row, half the intensity on the row above it. And yeah, and then it'll anti-alias out. Brain hurts is a mood. Yeah. For me, inverting the y-axis and then going down, which is up is down. I don't know. Like, at a certain point, the gear is locked up. I'm running out of coffee, so I just left it at normal screen space coordinates. So 0, 0 is top left, and then I'm mirrored on the video, whatever. So 0, 0 is top left, and then a positive slope goes down towards the bottom right of the screen. How do you get on the server again? I haven't actually made accounts for you guys yet on the server, so don't worry about it just yet. For now, just focus on the Unreal Engine, get that blueprint thing working. It's something I always want to talk about in IS-50A, and I've just never gotten around to. So get the animations working. It's a really important part of gaming, and once you do it, you'll understand it's not really that big a deal. There's just sort of, you just gotta work through a tutorial. But we're gonna be talking about drawing lines, drawing triangles, like, and there's math, but you kind of just gotta get used to the math a little bit. I think it could be explained in such a way that it's not really that bad. As long as you understand a little bit of 8th grade algebra, it should be fine. This is something you'd like to see often. Yeah, I mean, there's all sorts of things. I've been going through ray tracing tutorials and things like that. Like Scratch Pixel is actually a really good site. They've got all sorts of good things here. How cameras work, the projection matrix in OpenGL. That I might actually have you guys write this one. That one I'm thinking about doing as an assignment. Drawing a triangle by scanline. Last time I think we talked about you can draw a triangle by using cross product, which they actually have on here. I was actually surprised because it's kind of terrible. What they do is they go over every pixel, and if the cross product is negative for all of them, then it draws. I think they might do a different. Yeah, but it's basically cross product. So you can test to see if a point is inside. If it's inside, you draw it. But the recommended way is you just draw horizontal lines like that. And you use the line equation. So you've got one line here, you've got one line here. You figure out for the current row where the starting point is, where the ending point is, and you just do a for loop across. So for the current y, yeah, you figure out where the y-intercept is here and here. And yeah. And it's 2 lines instead of 1 line. And that's the starting point, that's the ending point. It's all horizontal lines. You don't even have to do anything crazy. And you just fill in a triangle that way. So you do triangle drawing that way. This is somewhat similar to what we were doing a little bit. And this is what we talked about before, drawing a triangle using cross products. Okay, so yeah, maybe I'll have you guys do this over the weekend. Something like that. It's kind of nice to know what anti-aliasing is. You used to not know what that setting meant. Yeah, if you have like a high resolution monitor, like if you got a 4K monitor, like anti-aliasing is really much less of a problem than it used to be. You only have to turn it on a little bit, and that'll get rid of the worst of the jaggies, because the jaggies are like really tiny now. You know, so if you have like if you have a 4K monitor, these pixels are like the size of a hair, you know, and so just doing a little bit of anti-aliasing is enough to break up the jaggies. Really, what you want to avoid is the moire patterns, the moire pattern temporal anti-aliasing, which are rounding effects that you get from like moving forward. So as you like walk forward on these texture patterns will shimmer and glow, and it's really, really distracting when you're like walking around. You get these moire patterns on textures, and so having some sort of temporal anti-aliasing that deals with it, mapping will also help with that. So here are different anti-aliasing methods to deal with jaggies and things like that, but also graphics cards can generally do anti-aliasing pretty cheaply these days. Like they don't really lower your frame rate too much. Some ways do, that's for sure. Like one way you can do anti-aliasing is just to render 4 times the pixels. So rather than doing 4K, you do like 8K, and then you average them down. That can be expensive, right? So you just render it at quadruple the resolution, and then you just use that to figure out what the thing should be. That can be expensive, yeah. But there's all sorts of different algorithms, and just play with it and get something that looks good. I think this looks pretty good. Like I think that's about as reasonable as you can expect. We're basically done, but let me give you guys full 4K resolution. You ready for this, putty? All right, so we're going to do a 45-degree angle, y-intercept of 0. There you go. So that is at 4K resolution. That is a line. That is a line. Anti-aliased line. Probably doesn't even come through on Discord. And we'll do it again with a slope of 0.25. Do it again with the slope of 0.1. You can see the anti-aliasing kicking in there. Slope of 2 with no anti-aliasing. Right, because we flipped the y-coordinate on the other one. Right, so I didn't set that one back. Slope of 3, no anti-aliasing. Slope of 5, no anti-aliasing. And so you can see, like, if you really squint at the monitor, I don't know how much of the resolution is coming through on Discord, but you can see these lines here don't have anti-aliasing turned on, and so you can see like that kind of noticeable stair step on them, whereas these it's a much smoother looking line. And these, it's kind of banded. It's kind of a weird look. Yeah, the stair steps are obviously much more noticeable on these. Remember when you showed high definition pictures in CSI 40 on putty? Yeah, yeah. Yeah, so this is my colors library rendering it's not 4K, it's I think 2K maybe 1080p, I don't know, somewhere in there. It's rendering every pixel out of an image on the screen in putty. What's the matter, Duncan? You've never seen a terminal do 24-bit color 4K images before? Yeah, it's not very fast, you know. It's not like we have a GPU acceleration or it's most definitely not something that Putty is even designed for. If you try scrolling Putty, it'll massively lag. I'm trying to scroll and Putty's just like, and then it Putty stops responding. Yeah. Someone else did something similar. Yeah, after I posted this, a couple people said, "Well, what's your advantage over these other people?" But I don't care. I like mine. I made it. So. Terminal images. Yeah. Does it do 24-bit color? Let's see. So using a character map. Yeah, I don't do that. I'm just reading all the pixel data and just outputting 24-bit color. So. How you doing, Putty? Yeah, there you go. Kept coming back. Okay. All right, that's it for today, guys. It's so poor Putty. It's dying. It's dying. I reported the bug to the Putty people, and for some reason I didn't get a response. When I try drawing a 4K image in Putty, it doesn't run very fast. You're a what now? Okay, so that's it for today. Do the demo that I posted onto Discord. It'll be up on Canvas, and I'll turn it into an assignment so you don't have to remember it. Just get that done by Thursday. It's 20 minutes of your life. It shouldn't be too bad. And then we'll pick up more talk about math and rendering and stuff like that on Thursday. And hopefully it'll be, reasonably easy to understand. It's not, I think, too bad if it's explained properly. It's not always though. Okay. That's it, everyone. Thank you.